Good morning, everybody, and welcome to this morning's session, again, as part of Berlin Science Week. So this session has been organised by Confirm. Confirm is a Science Foundation Ireland funded research centre based in the University of Limerick in Ireland. As I said, we're based in the University of Limerick, but we're spanned across 8 other academic institutes in Ireland. And our research focuses on the area of kind of smart manufacturing and Industry 4.0 and all the kind of technologies that enable industry to adopt both Industry 4 ideas and smart manufacturing and kind of transition to a smart manufacturing ecosystem. So one of these is additive manufacturing, which is more commonly known, I suppose, as 3D printing. And that's what the discussion is going to focus on this morning. So I'm joined this morning by Professor Leonard Sullivan, who's based in the University of Limerick as well. I'll introduce Leonard properly in just a second. But just to make you aware that the Q&A functionality will be open throughout the discussion. So I'd encourage everyone in the audience to submit questions based on Leonard's presentation, and then we'll get to those at the end of the session. So I suppose I'll introduce you to Leonard now. So Leonard's an associate professor at the School of Design in the University of Limerick, as I said. He's also a funded investigator with Confirm Centre. So Leonard leads the Rapid Innovation Unit, which is based between the University of Limerick and the University Hospitals Group, which is also based in Limerick. So this unit focuses on the use of 3D printing and other smart technologies to rapidly develop solutions for healthcare. So his group has applied this formula to several clinical specialisms to date, including neurology, gastroenterology, respiratory medicine, nephrology, assisted reproduction, and palliative care, among others. So Leonard, I'll hand over to you now, if that's okay.
Yep. Thanks very much, Sean, and hello to everybody in our audience. It's a great pleasure to have the opportunity to share with you some insights and also to give an overview of how such an exciting technology as 3D printing and additive manufacturing is being used today in medicine, and also to give some insights as to how it can help transform the care of patients in the years ahead. I'm based in the School of Design in the University of Limerick, and my area of expertise is actually human factors and ergonomics. And our team are very interested in using smart manufacturing to help create user-centered design solutions for healthcare. We have the benefit of a multidisciplinary team in our group, and that's also really important in how we look at advancing 3D printing. I think up until quite recently, and even today, the traditional model of manufacturing involves, especially of medical devices, involves, traditional manufacturing lines, often in specific areas around the world where parts are manufactured in volumes to certain sizes and then shipped internationally across supply chains to the hospitals where they're required. But the developments with this super exciting technology, 3D printing, is actually going to completely transform the types of care that we can deliver for patients in terms of being able to treat people differently and better. So with this, I'll bring you on a journey of some of our insights. I suppose just very briefly, just to mention that in terms of the terminology and how we look at it, I mentioned the traditional model of how we make devices. We have, where parts, plastic or metal are often, processed, where we remove material to form a shape. And this is traditional molding type processes as well. So this is where we have what we call subtractive machining, to remove material to find, a desirable shape as necessary. But with additive manufacturing, we're using material to ultimately build that shape, typically layer by layer, to form. Now, when we look at these two at a very simple level, they may not seem very different, but actually it really transforms the way in which we can make devices. And I suppose just in terms of the terminology, in its earlier days, this was often called rapid prototyping. And then more recently, it's called 3D printing, or also additive manufacturing. And I suppose just to take a moment to just show how it is that the process that typically that's involved in using 3D printing, be it, for example, wanting to make a new concept for a medical device or whatever the case might be. So someone will typically have an idea for the shape and form of the part. They'll convert that on the bottom left here into a CAD model of a form. And that is then converted into a particular digital file format in preparation for 3D printing. And then it needs to go through what's called the slicing software to prepare the file for the layer orientation and shape for the printing. It goes into a printing setup software. It then goes into the 3D printer itself, and that creates the overall shape. There's also a step called post-processing, which is very important, where either some build support material needs to be removed, or the part needs to be subject to a curing process, for example, through UV light exposure to harden the material. And that then brings us to the final product. So I think it is important just to recognize that sometimes when people hear 3D printing, they think it's a very simplified process that is, you simply press a button. There's not. There's a number of steps to that. And there's a lot of exciting research ongoing across these various steps to further see how we can improve and look at the opportunities for this technology. So when I talk about the technologies, there's actually, in terms of 3D printing technologies, there's actually quite a lot. Now, I don't expect you to be able to read this image in detail, but what I just want to show here is that there's actually quite a lot of different 3D printing technologies themselves. However, they're also expanding quite a lot because there's such huge interest in the principles of being able to additively make products. And those products, I might add, go from some very large products down to real nanoscale products or devices. And this is also really exciting. In terms of the technologies, you'll be able to see these in detail as well on a general internet search. So I suppose just to take a moment in terms of the scale of how such technology is being used. This is a recent example in relation to concrete and manufacture and how 3D printing can be used. So that's on a pretty large scale. We have other really exciting advances in terms of how 3D printing is being used, for example, in space. And here we have examples of, for example, tools that instead of our space missions requiring to bring a huge number of tools and devices that may or may not be used, the idea is that with a 3D printer on board, those devices can actually be printed to order if required. But there's also some really exciting work ongoing in terms of 3D printing technology in space, where there's other physical aspects such as gravity not present, which makes the technology advances there also super interesting. So this image here on the right actually shows from a relatively recent case study, a little spanner having been printed for a maintenance task. So that's super exciting as well. So I suppose just very briefly, we want to now kind of concentrate on the aspects associated with healthcare and medicine and hospitals and the potential use of 3D printing. But I suppose leading into that, we want to take a moment just to look at some of the really important benefits and advantages of 3D printing. It's a relatively quick time to print something, especially from concept through to prototyping stage. And, this, you can literally, in our lab, you're down to a few hours. Once you have a CAD model, we can have certain devices printed within a few hours. It's actually really relatively straightforward to print quite complex parts in one step. And alternatively, in traditional manufacturing, where you have to machine parts, it can be really, really difficult. And this technology is really, really good for prototyping. And from a design perspective, this is very important so that we can develop ideas very quickly. It's also really important in healthcare in situations where bespoke devices might be required for a patient, that moving beyond prototyping, parts could maybe be printed in a hospital setting for a patient within a few hours. In terms of 3D printing, there's relatively little waste in comparison to other manufacturing technologies, but there is a growing area of interest in the area of sustainability from a 3D printing point of view, because there are chemicals, materials required, but we can also cut down on supply chain costs associated with shipping physical devices. It's good to use, in particular, it's particularly good for low volume parts and especially for bespoke medical devices, as you'll see in some of the case studies in my presentation here today. As I mentioned, there's a lot of new technologies emerging, which are going to offer really, really important opportunities for treating medical conditions that have not been sufficiently addressed through conventional manufacturing means. There's also, once the technologies evolve, there's also involvement of the materials that are going to have new functions and forms that can help to treat patients in ways that have not been done previously as well. So I suppose in terms of where does the future lie for 3D printing, one of the terms that has evolved in recent years actually is point of care 3D printing. Now, the point of care is ultimately the hospital or a hospital network. And the whole idea around how we can use 3D printing in a hospital. So instead of requiring medical device manufacturing factories dispersed globally, the idea is to move smart manufacturing machines, 3D printers, into the facilities of a hospital or maybe very close to a group of hospitals, so that parts can actually, medical devices can be printed to order as they are required and delivered to the hospital, possibly within a day or maybe a short number of hours. So hence the term point of care 3D printing. I suppose the concept of using 3D printing in medicine has actually been reasonably well studied in terms of developing anatomical models. And this certainly is where some of the earliest advances of 3D printing in medicine have been. The idea of creating either anatomical models that had certain features that could be used as part of medical device design, or printing anatomical models that could be used to help explain surgical cases to patients, to their families, and also within the clinical teams for surgical planning, so that the physicians and the nursing staff can understand as best as possible the patient's specific clinical condition, especially for complex medical cases. Now, the earlier cases of 3D printing of anatomical models were based on using single materials and they didn't have color pigmentation, whereas this technology, again, has also really improved phenomenally, actually, in the last number of years, because we now have color 3D printing as well, which means that we can create color anatomical models, which are really lifelike. So we just see some examples here from some publicly shown cases. So I suppose just what happens in a situation like that, in terms of where, for example, we have a specific patient who's going to have a complex surgery and we want to create an individual's anatomical model. Well, first of all, they'll typically go through a process as shown here, where they go through a scan. We'll have something like a DICOM images, which are from those medical images. Those images are then what's called segmented, and where the particular structures are extracted, as shown here in the top right, and reconstructed into a 3D model. And then the 3D model can be 3D printed, as shown here in the bottom left, to give, in this case, an example of the skull. And that can then be used by the clinical team. Now, there's a huge variety of different examples that have been done internationally. And just to say, this area has been well advanced and is probably 10 years plus a little bit in terms of its practice in use. So, here's an example. Once again, this is from the web, and just shows the idea of a physician having an actual model in their hand that they can probably use and orientate in the clinical setting while they're either planning for a surgery or otherwise performing it maybe. So, and I suppose just to bring that on a moment then, there's actually a number of large companies who offer these types of services internationally. One of the very well-known ones is called Materialize. And if you're interested in some more detail about the types of functions and things that they can do in this area, if you log onto their website, you can see some of their case reports. And here are, once again, just some examples. So what I want to convey here is the fact that some segments of 3D printing in medicine are now very advanced. The segment looking at 3D printing of anatomical models, bespoke anatomical models, has now advanced quite well. So that part is quite mature, and there's companies who service the industry. And indeed, I'm aware of some cases in the US and in the UK where individual hospitals have services of some of these type companies where they will actually print anatomical models to order, and there's a bureau type relationship commercially between those entities. But what does the future lie ahead look like? It's actually, it's groundbreaking when we consider what can be achieved using 3D printing technology. And when we stand back and look at the many disabilities and medical conditions in life that have current treatments, which are considered to be sufficient because they are a solution. But now we have an opportunity to see, well, really, can we offer those patients even better solutions that can have a transformative impact on their quality of life? So in the area of prosthetics in particular, there has been a lot of developments recently. And of course, the nature of prosthetics, where someone might lose their limb, either because of a congenital condition or because of a road accident, or maybe because of a military exercise, we have situations where everybody's body is different. So you don't get a one size fits all when it comes to a prosthetic. So the idea of being able to scan an individual's limb and make 3D print prosthetic perfectly fitting devices to that individual is also really exciting. So now that area has advanced quite well in recent years, but there's also now the opportunity to look at not just the fit, but the function and how the materials can be enriched to make that prosthetic even better for these patients. Moving on, and we look at an example such as the 3D printing of casts. And, you know, when some of our family members are unfortunate and might break a limb, we're very familiar with a lot of the conventional technologies for making casts, which have remained the same, largely the same for many, many years. And they perform a reasonably good function, but could they be better? Well, here we have an example of asking that question in relation to arm splints. And, you know, maybe with an arm splint like this, you can actually have a shower and it can naturally dry. And as well as that, the skin has the benefit of air being able to have some surface contact. And there's also been quite a lot of work looking at the clinical benefits, for example, of 3D printed casts in terms of the actual benefit for the patient in terms of being able to very carefully control the size and the shape of that cast when it's actually been designed and fitted for the individual. Moving on then, in the area of orthopedics actually, which largely deals with surgical procedures around treating bone conditions, there has been a lot of advances, in particular where metals, 3D printed metals have been used. And what I would say is that in terms of where 3D printing has been used in medicine, one area I've said is anatomical models. The next area where parts have been 3D printed and used directly with patients has been 3D printing of metals in oncology. And 3D printing of metal is pretty complex stuff and requires very carefully monitored environmental areas because of risks associated with dust and so on. But it's one area that has advanced really, really importantly. And while we have a lot of medical devices for orthopedic procedures, such as hip implants, there are many cases with patients where they would really benefit from a bespoke solution. In some cases, patients have bone tumors on, for example, parts of their pelvis, where part of the pelvis has to be removed. So the option of being able to create a bespoke 3D printed mesh to replace that bone that has been surgically removed that can be integrated with a hip, like that has a phenomenal and a transformative impact on these patients that might not be served by existing medical devices otherwise. So just as another example here, once again, from the internet, looks at the area where patients may have, for example, part of a skull which requires a form of replacement, and how materials and 3D printed parts, for example, you could scan one side of the head and reverse engineer to fit the other side and to also fit in with the void area. And once again, evolving a little bit further again in the area of oncology, looking at in relation to orthopedic surgery associated with the chest area. And of course, the chest, and where we have our ribs and sternum, it's a complex and kind of, it's a naturally moving part of our body. We have several medium-sized bones which stitch in together, but yet our chest, as we breathe, we actually have natural movement. So there's been phenomenal work in the area of 3D printing of chest sternum replacements to address situations where, for example, maybe where patients have cancer of the ribs, where the ribs need to be removed to a point where we can help to replace those. So once again, this is based on metals and it is pretty well advanced. Another area then looks at how we can develop cutting guides. So once again, if someone has a surgical procedure and is actually having maybe part of bone removed, once again, maybe because of cancer treatment or otherwise, in advance of the surgery, we can use 3D printing to scan those bones and to 3D print, in this case then using some polymer-based materials to help design those cutting guides such that when they go to the open surgery, they're prepared, they can put these devices in place and use them for cutting the actual bone as is necessary. Moving on there, then some other really high-tech advances move over to tissue engineering, which is also can be a form of 3D printing. And when we think of the opportunities this provides for organ replacement and so on as well, I think it is really, really at the forefront of science and at the advances of what we're going to have available, hopefully in the years to come for treating our patients. And also then another area that's very interesting when we look at 3D printing is the area of income kind of across the globe in relation to medical devices. And in certain areas around the world, in developed countries, we have the benefit of access to, literally the cutting edge of medicine and technology to treat people. In some other areas around the world as well, we have low income groups. And, if we take, for example, the area of prosthetics for children who may have a residual limb in some low income areas of the world, the idea of having a prosthetic limb, which needs to be replaced every 1 to 2 years as a child grows, can be financially prohibitive. But there's a really important area of makers internationally who are looking at the idea of being able to share designs, and where we have people in low economic communities internationally where they can use relatively cheap 3D printing materials in files that are publicly available to help make devices for these patients that would not otherwise have access to some solutions. It may not be as good a solution as we might have with, a modern healthcare systems, fully funded scheme, but it's a good solution for someone who has no solution otherwise. And I think it's very important in how we look at this technology across communities as well. In terms of our group in Limerick, I'm going to share with you now just 1 or 2 examples of how we have looked at applying 3D printing at the forefront in hospitals to help improve patients' quality of life and their clinical care. In this example here, we have a teenager with a form of cancer called rhabdomyosarcoma. And in this situation, this is a form of cancer that targets young people. And in this situation, the young gentleman was in a hospital, which is in Ireland, is a hospital where people go for treatment when they're terminally ill. And in this situation, the individual had a tumor behind one of his eyes, his left eye. And ultimately, he did not have clear vision in the eye. The eye was protruded outwards. He was unable to blink. He had a perception of light, but no vision. And his carers required to give him various dressings to try and keep the eye moist and also to keep out some of the light. So our team, led by our researchers in the Rapid Innovation Unit, worked with the clinical professionals in the hospice to get a very deep understanding as to what they required to assist this individual. And actually, they reached out to us looking for a solution. So we worked with the team. It needed to be a completely close-fitting solution. It needed to keep the light out. It needs to be moist retaining, and it needs to be comfortable to wear in particular. So our researchers scanned the individual's face, created a bespoke eye cover solution as shown in C. And in D here, we see that fitted to the individual. So this helped to improve the individual's comfort in the latter stages of the individual's life. Now, this individual has since passed away. They were terminally ill. So we're hugely proud that we could use this smart manufacturing technology to provide some degree of comfort for them in the latter phase of their life. And this is a case in point of using smart manufacturing technology with 3D scanning technology, working at the boundaries between manufacturing and a hospital to create a solution that was not available otherwise for a patient such as this. And I might just add a detail that this clinical condition has a prevalence of between 1 in a million and 1 in 2 million. So this is quite a rare condition when it occurs. A second example I'll just show briefly relates to another case study we performed in our group some time back. In this case, we had a teenager who has had cystic fibrosis. And cystic fibrosis is a clinical condition that affects people's digestive system and also their respiratory system. And for some patients, they require a feeding tube, which is called a PEG tube. And they are given their nutrients directly into their stomach a number of times per day. In this situation, the teenager had the tube for a lot longer duration than would ordinarily be required with a typical feeding tube, which is short duration in the hospital. And because the patient was unsuitable to have it replaced, sorry, I should just detail it. There was in the middle image here, there was a leak in the tube, and the care professionals were unable to feed the teenager adequately without the fluids leaking out. But the teenager was unsuitable for surgery because of their clinical condition, so the feeding tube couldn't be replaced. So our team developed, as you see here on the right, a cuff which went over and sealed the leak. It was designed, delivered, and fitted in less than 24 hours, which meant that the teenager was then able to be successfully fed their normal feeding solution at that point. And that's a real important example, again, of the rapid use of this type of technology. And I might just add that the last example and this one have been published in scientific journals. So hence we're allowed to show the images. And maybe just on that, it just highlights the importance of us sharing these results internationally so that others can also see how this technology can help advance clinical care. And I suppose just to briefly mention then, this is my second last slide. I mentioned earlier how materials and technologies are developing. And as technologies are developing, people are looking at clever new ideas for new materials. Here on the bottom left is an example of some work from our own group, where we discovered that a lot of current 3D printing materials don't show up naturally on X-ray. So we developed a novel solution, which is subject to a patent application, where we can 3D print a replica, for example, of a hand, but we can actually have the bones within that hand impregnated with a material that shows up on X-ray. Now, this is really important for, in particular, clinical training opportunities, and we're working closely with clinical colleagues on other advances here. And also as well, one of our PhD researchers, Alice Shannon, is looking at, for her PhD topic at the area of antimicrobial materials. And that builds on the previous medical example I just showed you around when we have devices, maybe in contact with a patient's skin, that we can have antimicrobial properties to have this added clinical benefit. Thank you for your time and attention.
Thanks so much, Leonard. It was an absolutely fascinating presentation, and I think it's really inspiring to see the work that yourself and your team are doing, making such an impact on patients' lives directly. So thank you so much for sharing your slides with us. So just remind the audience that the Q&A is open. So if you have any questions for Leonard, please pop them in now if you have them. I suppose I did have a question, Leonard, when you were going through your slides there. In particular, it was just about the slide where you had the pelvic, the implant. You're saying where it was implanted in the pelvis. I was just wondering, like, could those be like how are they actually placed in the body? Like, do they integrate with the body, or are they just held in place with some
Yeah.
I'm sorry, I don't have the medical terminology now to ask the question properly, but
yeah. Well, actually, in terms of adhering metal parts to the body, that is already done quite a long time. So if someone currently has a hip replacement using conventional manufactured materials, for example, metals, they use typically bone cements or medical grade screws. Okay. And so, for example, sometimes people might, break their arm and they might have a plate inserted. They'll typically use some medical grade screws with metal plates to help stabilize. So in this, and another area where there's very exciting research ongoing is in the area of medical grade cements. So for example, coming back to that example there, the design team would have created the 3D model of the pelvis and how it would fit with the hip. They may also, now that we weren't involved in that, that's from a public source, but they may also have 3D printed, for example, the pelvis in a plastic material to check the fit. But in terms then of how it's actually adhered together, they would use a combination of screws, plates, and possibly medical grade cements.
Oh, perfect. Cool. Thank you. that clarifies it for me. Thanks. I suppose another part I found very, very interesting as well was this idea of tissue engineering. It just seemed like, it's quite an unusual material to think about when you're thinking of 3D printing. And I remember reading a couple of years ago as well, I think it was a couple of years ago at this stage, it was a paper about 3D printing of actual medicines, like pills and things like that. So I suppose it just got me thinking about that. How is, like, in terms of the tissue engineering, like how could you give a bit more information on that if you have it? I don't want to put you on the spot here or anything. But
well, what I can say is in our group, we're not involved in tissue engineering.
Yes, of course. Sorry.
So I'm very much on the periphery of it. But it's just a phenomenally exciting area when we think of, how we can, we consider people who have medical conditions that would benefit from tissue engineering. It's really exciting. I'm not versed in the finer detail of the technology, but what I can say is it's rapidly evolving, and it's very important for I think scientific developments that continues. One area where there's also a lot of interest in development is in the area of 3D printing of pharmaceuticals, in the area of 3D printing of ultimately tablets and medications. And actually that's evolving quite quickly. For some of the areas, the process of compounding pharmaceutical drugs is reasonably straightforward. But yeah, and actually as part of a recent systematic review that we did, we noted that there was actually quite a lot of activity in the area of 3D printing of medicines at the moment.
Absolutely, yeah. No, it's really, really fascinating. I suppose when I think of 3D printing, by the way, I don't have any expertise in this area, but I just automatically think of plastics, you know what I mean, essentially. But yeah, no, it's absolutely amazing. I think another thing that popped out as well, just it's not really a question, I suppose, just a point. You mentioned about 3D printing in low-income communities. And I think that was something that popped up in a panel discussion we had yesterday as well as part of Brennan Science Week. Just showing, how these technologies can really make an impact, both in people's lives in the medical sense, but also in a wider kind of societal sense as well. So that was a really interesting point, I thought.
Yeah, it certainly is. And just to briefly mention again, like one thing is for, developed countries to be able to have the state of the art and look at, having maybe even the luxury, if we say that, to the latest developments. But I think in all fairness, the big medical device players internationally, as part of their corporate and social governance, are also looking at the international space and how, if they develop technologies for America, for Ireland, for Germany, whatever, how they might be able to, as part of their models, fit those into low-income countries. Because, yes, they want to make money, but they also want to treat patients.
Yes, exactly.
So I think the business models that will evolve as well in parallel will be very vitally important. There's another area that's crucially important, which is the whole area of intellectual property. And is there an opportunity, or might there be a shift away from patenting designs to controlling the manufacture? And that completely kind of changes the model that we might have for future manufacturing of medical devices.
Absolutely, yeah. It's kind of bringing that idea of human centric. You know what I mean? It's kind of focusing on the human a bit more. I suppose one question that popped in there from Michael Leonard. He was just wondering, where is the research for the sternum and rib reconstruction being completed? Would you have an answer to that?
I on the slides, I have actually some of that material I've taken from public sources so that it could be shared. So if that contact wants to drop me an email, I can share those details with them. I can't say it straight off the bat. I don't have it in my mind, but if you drop me an email, leonard.sullivan@ul.ie, I'll be able to share those details for sure.
Great, thanks. Thanks a million, Leonard. I suppose I just had one final question around, I think you mentioned COVID-19 and the applications of 3D printing in that respect. So I believe, just from my own hearing about it myself on the news and such, that there was a big move towards 3D printing of devices for, I suppose, healthcare workers during COVID-19. And I believe you had some involvement in that as well. So
yeah, we certainly did. And actually, I think it was a huge learning exercise for the industry for 3D printing. And there was pros and cons, I will say. First of all, like many other groups who had design capability early in the COVID-19 pandemic, our local hospital group reached out to us looking for assistance for things they were in short supply of. And there was a phenomenal movement internationally as well, where people were wanting to contribute. And I think what we felt ourselves was, and what we learned was, early on, we said, there's certain things, devices, which we're comfortable with maybe 3D printing. But there's a lot of other things that it would be wrong to 3D print. I think there's, the regulatory side of 3D printing is really important. These are medical devices. Some items are medical devices going into the human body, for example, are going to be treating an open wound. They still have to be respected as medical devices. And there's a regulatory kind of framework that still govern those. And even in an emergency pandemic situation, the medical systems internationally and the regulatory body said, okay, we can kind of give a little bit of kind of leeway here, but there's some devices you simply should not 3D print because of the risk it poses to patients. So I think what we learned a lot. Naturally, we published a paper on this in the journal 3D Printing and Additive Manufacturing, and lessons learned from 3D printing. We highlight the really important benefits in terms of people being able to respond quickly. But we also highlighted that certain things are suitable for 3D printing in an emergency situation. But other things, for example, certain respiratory devices where someone might be breathing something through a 3D printed component and there's a risk of, flashing material or otherwise being inhaled. So brings with it a risk. So, but saying that, we have to look at things in the round and the positive. I think that, fingers crossed, we won't have a pandemic like this, maybe ever. But if we did have an emergency situation, we have learned a lot in terms of how we could mobilize and the types of devices that are suitable for us to be able to mobilize with. But I think the pandemic also brought with it a tremendous advance in the use of 3D printing generally, which has given, it's a rising tide. It has raised the expertise across many groups, and in particular drawn attention towards the opportunity in medicine internationally in this area.
Absolutely, it's absolutely. I agree. There's lessons learned. I remember when at the start of the pandemic, looking at there was a lot of open source respirator models, being spread around online, and I was thinking about the regulatory aspect. So thanks for answering that. I just have a question coming in there, Leonard, as well, from one of the audience. First of all, thanks for the great presentation. So the question is around organ rejection. So can this occur, I suppose, with 3D printed parts or 3D printed implants? And also, if it does, could you please shed some light on how to overcome the issue?
Yeah, and this is a complex area, and the same way in which traditional manufactured metal components can also be subject to rejection by the human body. And this is like, and I think it's very important for us to consider for a moment the classification of medical devices. And for those that are not familiar, they typically go from a class 1, which is a relatively very low risk device, up to a class 2 and a class 3 device, which is an example of an implantable hip. And we can't just experiment with 3D printing a hip in a patient. There's actually a lengthy process there, and actually it's a very mature area, the area of 3D printing of bespoke devices. So companies have established a business model, several of them internationally, where they work with hospitals, and they've done an awful lot of work around the nature of the materials, and they do a lot of research in terms of the biocompatibility of these materials. And a lot of research has been done to assess, the likelihood of these materials being rejected or accepted by the human body. But they all have to be done in a very controlled and a traditional medical device process in terms of assessing them, maybe doing animal trials, doing biocompatibility trials and clinical trials before they get to a point where they're actually subject to a clinical study involving an individual. But that is certainly a slower area. And when you're looking at class 2 and class 3 medical devices, safety is paramount and has to be followed very rigidly.
Of course, yeah. Thanks a million, Leonard. I think we have one final question. This question comes from, it's an anonymous attendee, actually, sorry. So could you tell us about research in Israel for printing hearts? Weeks ago in the press, it was published that they managed to print veins, etc., elastic material. So I don't know if you've heard about that, Leonard. Or
I haven't seen that individual example there. What I can say is the being able to actually print, like, for example, a model of a heart in a flexible like material is actually quite achievable now. And we have one printer in our lab, and which is a good number of years old now, where we can print flexible type materials. But there have been various other technologies now where they've also been looking at. So for example, in the image here, you have a kind of an exoskeleton, a hard plastic here. But there's been a huge amount of activity in 3D printing research around flexible materials. And there's also then been a lot of research in trying to recreate the physical and the mechanical properties of bodily soft tissues, for example, veins, in order to be able to create an example such as a heart or a vein and sometimes these can be then, so you could take a scan of someone's heart, that's straightforward. You can create it in a 3D model, that's straightforward, and the next point is the materials advances in terms of being able to print that then in these soft tissues. And this is a hot topic of research at the moment. Now, what I don't know is whether that's a model that's printed with human for tissue for implantation into a human. Now that is another area. There's a huge amount of research which is really exciting as well at the moment.
Oh no, it's absolutely fascinating. So I think that's all the questions that have come in, Leonard. So I'd just like to say thanks again for your time. It was a fascinating presentation, and I'll definitely be keeping an eye on this space. It seems like a rapidly advancing area. So again, thanks very much for sharing your work with us.
Thanks very much.
Thanks, Leonard. So just to finish up, everybody, just to say thanks.